All right, y'all. So 3.6 is titled Solving Applied Problems. Okay, so when you see applied problems, they're usually talking about word problems, okay? So the first two questions are not bad. They just want us to translate a statement from a word sentence into a mathematical expression. So they want us to translate the statement. Sort of like we did in the 3.6 support the other day. So this one says the sum of three numbers is 50. So they just want us to translate this into a sentence using mathematical symbols. So the sum of three numbers, remember sum was addition. And we don't really know the numbers, so we'll just write that as an x plus y plus z. So that's the sum of my three numbers. Is your equals, and then that's going to equal that 50. So now, when you're finished writing out your statements, remember, when you're dealing with these systems, they want everything in order on the left side equal to the answer on the right side. So y'all, the same thing on this second one here. We're going to translate the statement again. So this time they say the first number is 50 more than the sum of the other two numbers. So y'all, once again, realize I'm talking about three numbers altogether. I got this first number, I don't know what it is. And then I got these two numbers, I don't know what they are. But I do know that these two numbers are 50 more than my first number. So since I don't know the first number, I'm going to let that be my x. Is my equals again. And then 50 more than the sum of the other two numbers. Well, once again, sum is addition. So my other two numbers being added will be my y plus z plus, remember, more than means plus my 50. Now, this is the translation of the sentence, but what they want me to do to this is get all my variables on the left side equal to my answer. So y'all, since the y and z are positive on the right side, we need to subtract the y from both sides, and we need to subtract a z from both sides. So you don't have any like terms, so I'm just going to put them in alphabetical order. The x was positive, the y and the z will be negative because we moved them to the other side. And that's going to equal, see, these are canceling on the right side, so all that's left is the 50. So now we got it in the form it needs to be in. Alphabetical order equal to our answer. So y'all, the first two is just getting you ready for these word problems that are coming up. Now, what I'm going to show you on these is how to set them up and then I'm just going to punch them in my calculator and solve them, okay? So the trick is actually being able to set up your equations. So this first example says in triangle ABC, the measure of angle B is 30 degrees more than 3 times the measure of angle A. So that's my first equation. I know that angle B is going to equal 30 more than 3 times A. Then it says, hey, the measure of angle C is 60 degrees more than the measure of angle A. Then they say, find the measure of each angle. So y'all, basically what they're saying is we got some triangle sitting here, and we got an angle A, angle B, and an angle C. And they want us to figure out what is the measurement of each of these angles. So the first thing I do know is this angle B here. B means equals 30 more than 3 times the measure of angle A. So 3 times A will be 3A, and then 30 more will be plus 30. Now remember, when we solve this later, we need the A over here, then the B equal to the 30. So we're going to rearrange this one in a second. But this will be my first equation. Second equation, the measure of angle C. So angle C is 60 more than the measure of angle A. So that's just going to be an A plus 60. So y'all, I'm going to get these in the right order. Remember, the A needs to be over here, and then my B column, and then my C, and equal to the 60 here. So we're going to move this A over here on the first one by subtracting 3A. And y'all, if you notice, when you move something from side to side, we're just changing the signs, like I said. Now, putting this in order, I'm going to have negative 3A plus my B. The A's cancel, and that's going to equal that 30. So that's one of my equations. Right here for this second equation, we're going to subtract A from both sides. So that equation will give me negative A plus my C. Those A's canceled, and that's going to equal 60. So now let me see what I got with my system so far. My first equation, negative 3A plus B. I'm going to leave space here for the C column, but this one equals 30. The second equation was a negative A. We didn't have a B on this one, but we had a positive C, and it equals 60. So notice, I'm missing a C on the first equation. I'm missing a B on the second equation. But y'all, if y'all remember the other day, I told y'all, we've got 3 variables. We got an A, B, and a C. Anytime you got 3 variables, you need 3 equations. Well, y'all, I got only 2 equations. But there's another equation out there that they think we should know about the angles of a triangle. So y'all tell me, what do y'all know about these 3 angles? Do y'all remember what it equals if you add all the angles together?
180.
180. So that means I could come in here and say, well, hey, angle A plus angle B plus angle C equals 180 degrees. All right, y'all got people in the waiting room. Let me let them in real quick. All right, y'all hang on a second. Oh, he must have got knocked down, and then one more. All right, y'all, I got them all in. All right, y'all. So, like I said, this equation you got to know on your own about the 3 angles equaling 180. Ooh, they all keep coming in on me. All right, I think I got it now. All right, y'all. So now I'm going to solve this on the calculator at this point. But if you wanted to, is anyone working them by hand? All of y'all are using the calculator?
I'm trying to do it by hand before I use the calculator.
Okay, so let me do.
Yes.
I'll do 1 or 2 of these by hand, and then I'll do most of them because most of these are sort of similar to this one. So what we got to pick is a variable to eliminate. Now, y'all, I'm going to give y'all a clue. Notice there's not a C in this equation. So we could add these 2 and get rid of the C. That would give us 2 equations. The one we got from adding these, and then this one automatically because it don't have a C. Or you could do that with this one because it's missing a B. Since this one's missing a B, we could eliminate the B on the first and third equations and use the other one for the second equation. So what I'm going to do here, I'm going to eliminate the C. But you're going to see something pretty cool happen on this one when I eliminate the C's almost. So here's the thing. If I'm going to eliminate the C here, I need to make one of these negative. So what I'm going to do is multiply the second equation by -1 so that I can eliminate my C here. So negative times negative makes that a positive A. Negative times C makes that a negative C. And then negative times 60 makes that a negative 60. Now this one, I'm just going to bring it down because I don't have to change that row. So that was A plus B plus C equaled 180. So y'all look here, the C's are now canceled. A plus A is 2A plus a B. That's going to equal 180 minus 60, which is 120. But y'all look here. I got this 2A plus B equals 120. The equation I didn't use while ago has an A and a B equal to 30. So bring that one down automatically. So you don't have to eliminate the C on it because it's already eliminated. So I got a negative 3A plus a B equals 30. Alrighty, so let me see what's happening here. I gotta eliminate either the A's or the B's on this. So y'all, it looks like the B's would be pretty quick if I just multiplied one of them by a negative. So I'm going to multiply the second row by -1. That'll make this B negative, and when we add them, they'll cancel. And all we'll have left are these A's here, okay? So I'm not changing the top row. So 2A plus B equals 120. We are changing this row, and all this negative is doing is going to change all the signs. So negative times negative makes that a 3A. Negative times B makes that a -B. And then our negative times 30 makes that a -30. All right, so let's see. We're going to add them together now. So 2 and 3 give me 5A. The B's cancel. And y'all, 120 minus 30 gives me 90. So one more move. We know what the A equals. So let's divide everybody by 5. So that cancels, giving us a 1A over here. And y'all, let's see, 90 divided by 5, I think that's what, 18? I now know that the A equals 18. So look, my original two equations. This one has an A and a B equal to a number. This one has an A and a C equal to the number. So I can find the B by plugging in for A here. I'm going to find the C by plugging in for A here. So we're back substituting now. So I'm going to put this 18 in for that A. So I got -3 times 18 plus B equals 30. All right, y'all, -3 and 18 is a -54 plus B equals 30. Add 54 to both sides. So now these 54s cancel, and my B is going to equal 84. So I now know two of the angles. All I got to do is find angle C, which I can put an A here and get C. I could use my, where'd it go? My A plus B plus C equals 180 because I know what A and B are now. So either equation. So y'all, I'm just going to back substitute. And I know A is 18 plus B is 84 plus C has to all equal the 180. So I'm just plugging into this one, and I'll solve this one for the C. So first we would add these together. 84 and 18 is 102 plus C equals 180. And y'all guess what? One more move, and that's to subtract the 102 from both sides. So y'all, those cancel. I got my C. And let's see, 180 minus 102 is what? 78. So if you go and add 18, 84, and 78 all together, you're going to get 180 degrees. Now, let me show you how you would put this in on the matrix. This is a 3x4 steel, so it's a 3x4 matrix. Now, the numbers you would put in, -3 for the A, 1 for the B. Y'all, what are we putting when there's not a C here? I got to put some number in that calculator. So if there's not a C here, what are y'all putting in that column? How about a?
1.
how about a 0? Remember, if something's missing, you're always going to put a 0 there. And then I'm going to put 30 for that row. The second row, I'm going to put -1 because that was a negative A. There's no B, so that's going to be a 0. There's one C, and then that row equals 60. Then my last row, 1, 1, 1, and 180. Remember, we only put numbers, but every place has to have a placeholder. And if that variable is missing, you're going to put a 0 there, okay? So y'all, let's go on the calculator, and we hope it gives us 18, 84, and 78, okay? So my matrix is second x -1. I'm going to go to edit and enter. So I've still got a 3x4 from the other day, so we're going to hit enter on 3 and 4. And then we're going to put in these numbers. -3 for the A, 1 for the B, 0 for the C, and those equal 30. And enter. Second row, I had -1 for the A, 0 for the B, 1 for C, and that row equaled 60. And then y'all, the last row, 1A, 1B, 1C equaled 180. And enter after that 180. And then it always puts the little highlighted box back up in the left corner. So we got this matrix in. So now I hit second mode to quit. Now remember, I'm going after RREF. So to get that, I got to hit second x -1. Arrow right, highlight math. And y'all, we're going to arrow down and get to RREF. So RREF and enter. And remember, for the third time, I'm going to do the second x -1. And then I'm just going to hit enter because my matrix is going to be highlighted. Since one's highlighted for what I just put in, I'm going to hit enter. All right, y'all. So now when I hit enter, it reduces and solves our matrix. And y'all look at that on the right side. They're in alphabetical order, starting on the right. 18, B is the 84, and C is our 78. All right, y'all. So let me go back to my pad. So they're sort of fun by hand. And then I like to use that calculator. It sort of checks me like you were saying. Sort of check your word just to verify. All right, y'all. So let's see what equations we can come up with the next one. So the sum of 3 numbers is 56. So 3 numbers added together are going to equal 56. Now they say the difference of the largest and the smallest is 51. And then it says, and the sum of the 2 smaller numbers is 13. Then guess what they say? Find the numbers. So let me tell you what I'm going to do here, because this is talking about large numbers, small numbers. So what I do is I'm going to let the X column be my largest number. I'll let Y be my middle numbers. And then my smallest number will be my z's. So I'm going to call these X, Y, and Z, and each one of them will have a number they're equal to. So the first sentence, the sum of three numbers is 56. That's going to be your X plus your Y plus your Z is going to equal 56. Now look at this one, the difference. So now we're looking at subtraction. So the difference of the largest, which is X, and the smallest, which is Z, but remember, that means you're subtracting Z because that's a difference. Those two equaled 51. Now, your third sentence said the sum, so we're back to adding, of the two smaller numbers. Well, y'all, my two smaller numbers is my Y plus my Z. And those are going to equal 13. Okay, so see, this is one of those. I won't do this one by hand because you would do this the same way I did the first one. But you're missing a Y here. So you could add the first and the third. Do what you need to do to get rid of the Y using those two. And then that would be your second equation because you'd only have X's and Z's left. Or you could cancel the X's here and you'd have Y's and Z's left, which would match this equation. So by hand, either way on those, okay? So now I'm going to show you what I would do to throw this one in the calculator. I'm going to put in a 3 by 4 again, 3 rows by 4 columns. 1, 1, 1, 56. Second row is 1, 0, -1, 51. Last row, 0, 1, 1, and 13. So y'all, this is what we'll put in. And for the answer, it'll say the numbers from largest to smallest. Are blank, blank, and blank. Now remember, since X is my largest number, X will be the top answer I get, then the Y, then the Z. So y'all, let's go plug this in and see what our three numbers will be. So second, X -1 from a matrix. I'm going to go edit to put this matrix in. It's already a 3 by 4. So I had 1, 1, 1, 56. All right, second row, I had 1, 0, -1. So 1, 0, -1. And that was 51. Our last row, 0, 1, 1, and 13, enter. All right, y'all, so everything's in. So now I can quit by hitting second mode. Now I'm going after RREF. So second, X -1. Go to math, and then arrow down. And enter. And then go get that matrix, second, X -1, and hit enter since one's highlighted. All right, y'all. So when I hit enter, we will now know our three numbers from largest to smallest. And it looks like my largest number is 43. My middle number is 21. My smallest number is a -8. And if we add all three of them together, they will equal 56. So y'all, they're not too bad. It's just setting them up, okay? All right, y'all. So this last one, I'm gonna show y'all how to set it up. This is show you how to set it up, and then you can either punch it on the calculator or do it by hand on it, okay? But I just want to mainly show you how to set this up. So by eating, by eating 1 egg, 1 cupcake, 1 slice of pizza, a child consumes 301 milligrams of cholesterol. So that's my first equation. Then it said if the child eats 3 cupcakes and 4 slices of pizza, the child takes in 90 milligrams of cholesterol. And y'all finally, by eating 2 eggs and 1 cupcake, the child consumes 566 milligrams of cholesterol. So they're giving us all these foods and telling us about all this cholesterol. So guess what? They want to know how much cholesterol is in each item. Okay, so I need to come up with my equations, and then I can throw them in my calculator and solve these if you wanted, okay? Or you can do these by hand. This one will sort of match these other two we've been doing. You're going to notice some missing variables on them, okay? So let's see what I got. I'm going to make my columns like I did here for my numbers. I'm going to let my eggs be my X's. My cupcakes is next. They're going to be my Y's. And the pizza will be my Z. So here, 1 egg, so 1 X. Whoops, I can just put an X there, I guess. 1 cupcake could be plus a Y. 1 slice of pizza will be plus a Z. All 3 together equals 301. All right, the second row, though, was 3 cupcakes. Well, that'd be 3Y. 4 slices of pizza, that'll be 4Z. That equals 90 milligrams. And y'all, my last one, 2 eggs, so that'll be 2 X's. And 1 cupcake, so that'll be 1 Y. Those 2 together equaled 566. So once again, notice you're missing an X here, so you could use these 2 to get rid of the X. You're missing a Z here, so you could use those 2 and get rid of the Z. Okay, either one, they're going to be very similar to that when working them by hand. Like I did with the triangles, okay? So once again on the calculator, 3 equations times 4 columns. Our numbers will be 111,301. 03490. And then 210,566. So y'all, you will be putting zeros in on that calculator if you're doing it by calculator, okay? So y'all, this is what you would punch in, just like we did up here. And then on the answer blanks, you'll have egg equals, cupcake equals, and pizza equals. So since that's the last one for 3-6, I'll go punch it in real quick on my calculator. So I'm gonna clear this off. And I'm gonna clear that history up over here. So second x negative 1, edit, and enter. It's a 3x4 already. So let's see, this is a 111. And a 301. And enter. Next row was 03490. And y'all finally 2 1 0 566. And enter. All right, y'all. So all that stuff's in there. So I'm gonna quit my screen. I'm gonna go get RREF by hitting the second x negative 1, highlighting math, and scrolling down. All right, so RREF. Now I'm going to go grab the matrix I just put in and edited by hitting x negative 1 and enter. And y'all enter. So remember, eggs was the top number, 274. Cupcake was 18. And pizza was 9. So y'all, that's the trick in 3.6. Is really just getting these equations set up out of them word problems, okay? Once you got your equations set up, solve them by hand, throw them on that calculator, and be done with them.
Sir, I have one question.
I hear you.
Could you go back to example 3 so I could take a picture of it real quick?
Which one was my example 3?
It was the very first one we did.
The triangle?
Well, not the yes, the triangles.
So take a picture of this top page, and then I'm going to pull it down.
Okay. I got it.
And then the rest of this whole problem would be right there.
Okay.
Now,
Got
this
it.
bottom part, I was just showing y'all how to put this part on the calculator.
Yes, sir. Thank you very much.
Okay. All right, y'all. So I'm going to do a few problems out of support for 3.7. It deals with graphing. So I'm going to use this graph paper. So the first one, they want me to graph y equals negative 1. So y'all, when you got y equals any number and you're graphing it, if y equals a number, this is going to be a horizontal line. These graphs are horizontal. Okay? Now, since they got y equals negative 1, that means every y value equals negative 1. It don't matter what the x's are. They're telling me y has to equal negative 1. So remember, here's your x-axis, here's your y-axis, there's my origin. So if I go down 1, that's negative 1 on the y-axis. Now notice, these are going to make horizontal lines, and no matter what these x values are, they're telling us that the y value has to equal negative 1. So in MATLAB, if you'll just come down, put negative 1, go right or left and click, make you a horizontal line there, MATLAB will come in and automatically draw that line for us. So remember, y equals a number, horizontal line. And y'all, if you was to make you a table up, you can pick any x's you want here. You can pick 0 and 1. It don't matter because y has to equal -1 every time, okay? So throw you some random x values over here. Make the y's equal -1. Plot 2 points. Draw your line, okay? That one was horizontal. Let's look at, what if I got x equals a number? How about x equals -4? So if you got x equals -4, it don't matter what the y values are. Every x value has to equal -4. So remember, here's my x-axis and my y-axis. So if every x has to be -4, that means that this is going to be a vertical line. Okay, so every x has to be -4. So y'all, every x value must equal -4. And once again, if you're going to make a table up, well, remember, every x has to be -4. So automatically, you're putting -4 for the x's. And then you can pick 2 random numbers to plot for the y values. It don't matter. Come to the x-axis and go find -4. So -4 is right here on the x's. So that would be -4, 0. Now remember, this is a vertical line. So at -4 on the x's, you can either go up 1, down 1. Once you plot that second point, MATLAB's going to come in and draw a vertical line there for you, okay? So remember, y equals a number. Every y value is that number. X equals a number. Every x value is that number. All right, y'all. Then they just want us to, so let me go back to my page now so I can give y'all some notes. So this is still support 3.7. But y'all, they want us to start graphing inequalities. So when you're graphing inequalities, inequalities are less than, greater than, less than or equals, and greater than or equals. So these are your inequalities. So when you're graphing inequalities, these are going to result in a shaded graph, and I'll show you how in a second. So first, if your equation has equals in it, if it has a greater than or equal or a less than and equals, when we draw the line, we're going to use a solid line. So I'm going to find 2 points and use a solid line to connect them, okay? Because the solid line means it's true for the equal part. Now, what if it don't have equals in it? What if it's just a greater than or less than? So notice there's not no equals on these. In that case, we're going to use a dotted line. When you use a dotted line, any point on the dotted line makes it false. It's not true, so that's why we use dots. It's true on this one with the solid line because of the equals, okay? So this, first of all, I figure out, do I want a solid line or a dotted line? Now we got to figure out, where do we shade? We either shade above the line or we're going to shade below the line. So if it's got equals, I mean, if it's greater than and equal or greater than, so if it's greater than, no matter if it's equal or not, but if it's greater than, we're going to shade above the line. Okay? Because remember, greater than and stuff like that, you can get more than one answer that makes these true. That's why we shade these areas for all the solutions that'll make them true, okay? So if it was greater than, it's shaded above. That means less than or equals, or less than is going to shade below. Okay? So this tells me what kind of line to draw, the first two. The second two tell me where to shade my graph at. So we're going to do an example. We're going to graph y is greater than 5x. All righty. Now, on all these that are solved for the y, you can graph these and it'll sort of look like what your pictures you graphing by hand. So I'll show you how to do these by hand, and then I'll show you how you can shade on that calculator, okay? So by hand, I'm going to make my graph here. And I'm going to go out about 5 to start. Hopefully that works. Alrighty, so I'm going to use a 0. If I put a 0 in for the x, 0 times 5 is 0. So one of my points is going to be right here at 0, 0, right in the center, or the origin. Then I'm going to use a 1 for my second x. If I put a 1 in for x, 1 times 5 is 5. So my second point will be 1, 5. So go right 1 and up 5. Hey, y'all, so I need 2 points. Well, I got 2 points. So now I got to figure out, y'all, do we want this line solid or dashed? What y'all think? So right here, we're talking about the line.
Dash.
Oh, I just heard it. It said dashed, right? Because remember, we got a greater than, and it said greater than or less than is going to be a dash. So we just dash our line through our points. Now listen, on MathLab, when y'all do the line, on MathLab, once you choose, you're going to choose the line tool, you know, the graph width first. Choose that tool. But right here, it'll have a solid line and a dash line. By default, it's on a solid line. But if you got a dash line, you got to highlight the dash lines in MathLab. You got to let it know you're doing a dash line, okay? So click on the dash line. When you pull out your 2 points, it'll draw a dash line. And then over here in MathLab to shade it, it has like a little paint can thingy. So when you shade it, you highlight the paint can and drag it either below or above your line. So remember, this is above the line on the left. This is below the line on the right. Based off this graph, am I going to shade this thing above or below? So y'all, that's a greater than.
Above.
Because it says right here, greater than, shade above. So in MathLab, you would bring your paint can over here, and it's going to shade everything to the top of that line there. anything we shaded, if you plug them into this equation, it's a true statement. Over here, anything that's not shaded would make that false if you plugged them in. Okay. So yeah, you can pick any points over here. This is shaded at 4. So 0, 4. X is 0. 4 would be greater than 0, makes that true. So all the shaded stuff is true. The unshaded stuff is false. So y'all, let me show you how to do this one on the calculator. Anything that's solved for y like this, we can actually do on that calculator. I'm going to clear everything off. So remember, the graph, we go to y equals, and my equation is 5x. Now, if you want to see what the picture of the graph is going to look like when I'm done, we got to tell it. Now, the only thing the graph won't do, y'all, it won't do dotted lines and the solid lines. It's going to make them all solid. So in MATLAB, you got to know to use a dotted line if it's less than or greater than, okay? Calculator won't show me the line, but it will shade it. Now, y'all watch what I'm about to do. I'm about to arrow left so that my cursor gets over here to the left side of the Y1. So watch it. It's going to go over. Now it's highlighting on the blue box in the line. I'm going to hit enter on that. So this is telling me what color it's going to shade. So I'm not going to change that part. I'm not worried about that. What I'm worried about is down here where it says line. If we want to shade above, we go right. This triangle right here, see how it's bigger on the top? This one shades above, and I'm going to click again, and that one shades below since it's bigger on the bottom. So you're going to arrow until you find the one that's shaded above like I got. You're going to arrow down and hit enter for OK. So now when I hit graph, it's going to graph it and shade it in blue, similar to what we did. And y'all, there you go. So when you're done, MATLAB needs to look something like that. Now remember, you can always hit second graph to get the table and find points. There's my 0, 0 I used. There's my 1, 5. Okay. All right, y'all. So back to hand. So let me do one more support one, and then we'll look at the 3-6 for college algebra, 3-7, I mean. All right, y'all. So here we go. So this example, graph x plus y less than 1. So this one, I'm going to solve it for the y. Remember, we want the y or inequality and then everything else on the other side, especially if you're going to put it on the calculator. So you want to move this x over by subtracting. So we get a y because the x's cancel. Y will be less than. Now, you can either put 1 minus x, or if you like that y equals mx plus b form, you can put negative x plus 1. Either way on that, okay? So let me get my graph ready. And y'all, I'll go out 5 again. I'm going to keep my number small. All right, so by hand, I'm just going to make me a little x and y table. Easiest numbers for me are going to be 0 and 1. So if you put a 0 in, 0 times that negative is 0, and 0 plus 1 is a 1. And y'all be careful. I'm going to put a 1 in, but remember, I got a negative sitting here. So when I put my 1 in, that's going to give me a -1. -1 plus 1 gives me 0. So remember, when you put a number in for the variable and you got a negative in front of it, that negative stays there. Okay? And it's going to make whatever x value you put in here basically negative. So 0 and 1. So starting at 0, go up 1. And y'all, my other point was 1, 0. So write 1 and stay at 0 for the y. So it's going to ask you first, y'all, are you going to use a solid or dotted line? So let's see. We got
Solid.
less. So less than dotted again. So remember, since it's dashed, that means in MATLAB, you got to switch it from the solid line to the dashed line when you draw it, okay? All right, y'all, are y'all shading this above or below?
Below.
Below. So below the line will be over here. All right, y'all. So now I'm going to go back to my calculator to show you again. But I'm going to go to the older calculator this time. I'm going to switch my calculator to a 84 plus so that you can see how I would do the greater than, less than on this one. So they're similar. It's just when you choose the upper and lower, it's different. So go to y equals. I had negative x, so that'll be a negative x plus 1. Now, remember, I'm going to shade this one below, so I'm going to arrow left. Now, notice on this one, it don't give you the colors and stuff. This is the old school calculator. So when you're over here, you just hit enter, and it switches between, look at that. There's the greater than. We needed less than, so we want the one. Less than shades below the line. So here's the one that's bigger on the bottom for less than. So then I would graph it. And y'all, there's our shaded area we just came up with. And once again, if you needed some points, just hit second graph. And I'm going to arrow down to get some positive numbers. So I use 0, 1, and 1, 0 on mine a while ago, but these are other points you could use too, okay? So, y'all, that's what they're going to do in the support for you, okay? So now I'm going to get us into 3.7 college algebra. And y'all, 3.7 is systems of linear inequalities. And y'all, what they mean by this, inequalities were my greater than, less than, and all that. Linear means these are line graphs like we've been drawing in the support part, okay? So it'll start out, the first one is just like the one I just did for support. So I'm going to show you how to do this second one. Because the first 4 problems is doing what we just did in support. Basically. So let's see. I wanted to do this one because it's got to be solved. And this is 2x minus 5y is less than or equal to a negative 15. So y'all, we need to solve this from y. Okay, we want this y less than equal or y greater than equal to whatever we get. So we need to move this positive 2x over by subtracting. So y'all, these x's cancel. My negative 5y comes down, less than or equal. And y'all, I'm just going to put my x's first again. So I got a negative 2x minus 15. So y'all, what's my next move? I need to solve that and make that a 1y. So how about we got to divide everybody by that -5. Because remember, -5 divided by -5, that's going to give me a 1y right there, okay? Y'all, remember one thing, though. I'm doing an inequality here, right? I got a less than or equals. I'm dividing by a negative number. So what's that mean? Oh, y'all forgot one rule, didn't you? If you divide an inequality by a negative number, you got to reverse that inequality. That inequality reverses and becomes greater than. So remember, dividing an inequality by a negative number then we must reverse the inequality. Y'all, that's one of the biggest moves I get people on. They'll come in and divide to make that y +1, and they forget to flip that. And if you don't flip it, you'll shade below the line instead of above the line like you need, okay? Because remember, -5 divided by -5 makes that a 1y right there. It is now greater than or equal. Well, here's a negative divided by a negative. That's going to make that a +2/5 x. Here's a negative divided by a negative. That's going to make that a +3. So y'all, let me get my graph ready. Let's see. I think I can still keep them sort of small. So I'm just going to go to 5 again. Or punch it on my trusty calculator, right? All righty. So I'm going to make my X and Y table. I'm going to use a 0 for sure. Because y'all, 0 times 2/5 is 0. 0 plus 3 gives me a 3. Now, let me think. We did fraction graphs like this the very first week. So let's see if y'all remember what my second X is going to be. Anybody remember what I might pick for my next X? So remember, how did I get rid of these fractions? Uh-oh, y'all slept since that day, huh? So y'all, here's my thing. Since I got a fraction, my next X is going to be a 5. Because if you put a 5 in for this X, it's going to cancel with this 5 on the bottom. And if them 5s cancel, all that's left is 2 plus 3, which is 5. So I always use 0 when I got fractions. And then my second X always matches the denominator. That way I can cancel the fraction and I just add or subtract whatever's on top, okay? So y'all 0, 3. Here's 0. Go up 3. 5, 5. I'm going to go right 5 and up 5. All righty. So is this a solid line or a dashed line? All right, y'all, that's on y'all. Greater than or equal. Solid or dashed.
Solid.
So I'm going to do solid. Good job. And are you going to shade this one above or below?
Below.
We'll go by this one right here. Always go
Oh.
by your final equation. And since this is greater
Above.
than, oh, I think I heard it.
And you changed it again because you moved stuff over, right?
Well,
Sorry, I missed that part. I was trying to write it all down.
so I didn't change it when I moved over to negative 2x. Remember, I left it the same here. The reason I changed it because I had to divide by that negative 5 to make that y positive.
Okay.
So it's when you're dividing by negative numbers, you're going to always flip it, okay?
All right. Thank you.
No problem. All right, y'all. So it does some of these kind of examples. I'm going to do one of them with a straight line. So let's see. I'm going to do the one where it's got x. So we're going to graph x greater than negative 7. Now, we just did some x equal negative 7 in support, Walgo. So here's my x and my y. So I need to at least go out 7, it looks like, because that thing's negative. So 1, 2, 3, 4, negative 5, 6, 7, 8, 9, 10. So I'll just go out negative 10 on this and then positive 10 right. I'll go up. And then I'll come down. So remember what we said about this. Treat this like an x equals negative 7. When you make your table up, remember, it don't matter what these y values are. We know that every one of these x's is going to be negative 7. Okay? You can pick 100 x's, but they all got to equal negative 7. And like I said, it don't matter what we pick for the y values. So usually the easiest two numbers are going to be 0 and 1. And remember, since this is x equals negative 7, this is going to be a vertical line when we're done, okay? So I'm going to do negative 7, 0. So there's negative 7, 0. Negative 7, 1 would be 1 up. At that point, we're going to draw our line through these 2 points. But my first question is the line solid or dashed?
Dash.
All right, so this thing is dashed. Now, here's the thing on this one. This is the only one. You really don't have an above and a below on a vertical line. But which way are the x's greater? Would you shade this to the right or would you shade this to the left?
The left. Or wait. Yeah, I would do the left. Is that right?
Well, because remember, you got to be greater than negative 7.
Okay.
So the more I go left, I'm getting smaller.
So the right.
Till the right.
Okay.
And I'll tell you a little trick on this. The x, this little thing points to where you're going to shade. When you're doing an x equation like that, yeah, that's pointing right. So that means I'm going to shade this thing to the right. Now, y'all, this is the only one you can't do on the calculator because remember, the calculator has to be in the form of y equals. And we can't do x equals and stuff. So this one you have to pretty much know by hand, okay? But in MathLab, grab your line tool, click the dotted line, and then drag the paint can to the right side, and it'll shade it. Oh, I'll do the Y one for you. Now the Y one is the only one. The Y one you can do on the calculator because remember, it's already Y1, Y2, Y3. So since it's solved for Y, you can do this one on the calculator. So let's see. I got Y less than or equal to a -2. So this one I'll go out 5 because -2 is not too bad. All right. So since this is Y equal to a number, I know every single one of these Y values will be -2. Because remember, when we plot this, it's going to end up as a horizontal line. X's are vertical, Y's are horizontal. So since every Y has to be -2, y'all, it don't matter pick any numbers you want for those X's. If you like negative numbers, do -1, -2. It don't matter. As long as the Y value is -2, okay? So 0 and then down 2. 1 will be right 1, down 2. So at that point, I got my 2 points plotted. Hey y'all, would y'all use a solid or dotted line?
Solid.
All right, so this one's gonna be solid. Now, shade above or below? Remember, y'all, less than,
Below.
below. There you go. Okay. Now watch y'all. MathLab will do that. Let me go to the calculator. I mean, not MathLab, but our calculator do that. Go to Y equals. And Y equal -2. It's less than, so I'm gonna go left, remember, and click that till I got the triangle that is below, bigger on the bottom. So there's above, that's greater than. That one's below, that's what I needed. So y'all remember when I graph this, I'll have a line going straight across and shaded below, okay? And then I'm going to do that one more time on the color calculator for those folks to see. So remember, my Y1, I'm going to clear this all out. I had -2. So I'm going to highlight to the left. And when I get on the blue box, I'm going to hit enter. So this time, say I wanted my line to be a different color for shading. Say I wanted to shade it green. And then we'll go down here and hit arrow right until I find that triangle bigger on the bottom. So that's above, that's below. And then go down and hit OK. And y'all, once I do that and hit graph, same thing, it shades it below that line, okay? And remember, if you want points, go to second graph for your table. And y'all look at every single one of these Y1s. -2, okay? So y'all, here's the thing. We learned all that shading for one problem that I got coming up. We're going to solve a system of inequalities. So y'all watch this. When solving a system of inequalities, the solution is the double shaded region. And what I mean by, I'm going to shade one of the lines first, then I'll come in and shade the second line where they overlap and they're double shaded. is the answer you would pick on MATLAB, okay? So that's how you solve a system of inequalities. You graph them and you look for the double shaded region. So look, for this example, they want us to graph the system of inequalities. So I got, and what's nice, these ones are already solved. I'll have y greater than or equal to x plus 4. And then I got y less than or equal to 1 minus x. So in the calculator, I would do y1 here, put in x plus 4, arrow left, and do the triangle above. This one, I would put in y2, put in 1 minus x, arrow left, and I would use a triangle bigger on the bottom. Okay? So the first one's the triangle bigger on the top. Second one, triangle bigger on the bottom. So greater than, less than on the calculator. So what I'm going to do is graph both of these by hand. And then I'll show you on my calculator, okay? And y'all, this is the last one, so all that shaded straight lines was just to do this one system. So I'm going to graph the first line first, and I'm going to use this first x and y for it. And since I don't have fractions, I'm just going to pick 0 and 1 for all my x's on these, okay? So the first one here, if I put a 0 in for the x, 0 plus 4 is 4. If I put a 1 in for the x, 1 plus 4 is 5. So y'all let me plot my first line and see what happens. So 0, 4, start at 0 and go up 4. And then I had 1, 5. So right 1, up 5. So the first line, solid or dashed. So let's see. Oh, we got equals. So these will be solid. Now, do I want to shade that first line above or below? We always greater than, and we said it's going to shade above. So this first line is shading all this above this line over here. It's shading all that. Okay. So now I'm going to plot my second line and see where they overlap. So the second line, I'm going to use this one. So if I put a 0 in for the x, 1 minus 0 is 1. If I put a 1 in for the x, 1 minus 1 is 0. So this one has a point at 0, 1 right here. And then at 1, 0 right here. It's also got an equal, so it's also going to be solid. Now I got to figure out where to shade it. Well, it was less than, so it shades to the bottom. So this line I just drew, shading under it would be this side. All righty. So MATLAB will have 4 pictures. The solution I need to pick for this one is the one that has this little square, triangular area shaded right there. Because that's the only part where it has the yellow section and the blue section. So I was trying to make that more green in here. But yeah, that's the double shaded section. So that's the only answer you want to pick, okay? So I'll show you what they're going to do to you on that one. They're going to shade the bottom section, the top section, the left section, which is what we had, and then the right section, okay? So they'll just go in and shade all the sections once you got the lines plotted. So let me do this one on the calculator and show you what it'll do. And then we'll be able to see how it'll shade, okay? Alrighty, so let me see. We'll clear out the old history over here. So my first equation, x plus 4. That one shaded above, so I'm going to go left. Hit enter. So I'm going to use yellow like I did a while ago on my paper. And then I'm shading above, so I need to switch that to above and then hit OK. All right, my second equation down here was 1 minus x. And that one shaded below the line. So I'm going to hit enter on the left side. And I'm going to use green on that one. And it was below. So let's see. There's above. There's below. So go down and hit OK. All right, y'all. So it should. Oh, hell, I wanted blue, didn't I? Okay, let me go fix that. I want it to be green like on my paper was supposed to be. So there we go. There's my light blue. So now I can tell it okay. So hopefully when I graph this, we get a green sort of shaded area on the left side. So there's our yellow across top, blue on the bottom, similar to a green on that left side. And y'all, what's nice, if you wanted to graph this, you could go to second table. The first column in Y1 here, that would be like -3, 1, -2, 2. Now, for the second line, you would use those same X's with those Y values that are in blue. So yellow is the first line with the X's. Blue is the points for the second line with those X's. Okay, so like my one, I had 0, 4, 1, 5. And then I would have 0, 1, 1, 0 for the Y2s, okay? So y'all, if you notice, today's stuff not bad. Most of everything we done today was pretty much calculator type stuff. Do them by hand if you like, or like I said, you could do all these on the calculator from today. So y'all, what I'm going to do, let me stop my share. All right, y'all, so I'm going to stop my recording and then I'll see what questions